So hi guys, the products generated at the electrodes during electrolysis depend on three basic factors. They are the position of the ions in the electrochemical series, the concentration of the ions in the electrolytes, and the nature of the electrodes used during electrolysis. But the question is, does the quantity of products generated at the electrodes also depend on these factors? No. It actually depends on three other factors. They are the magnitude of the currents passing through the electrolytes, the time taken for the electric currents to pass through the electrolytes, and finally, the charge of the ion discharged at an electrode. In this lesson, we'll establish the relationship between the magnitude of the electric currents passing through the electrolytes and the quantity of the product generated at the electrodes during an electrolytic reaction. To establish this relationship, we will have to consider Faraday's first law of electrolysis, which was published in the year 1834 by Michael Faraday. The law states that the mass of the elements liberated at an electrode during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. This means that the more the magnitude of the electric current passing through the electrolytes, the more the quantity of the product obtained at the electrodes. It is like fetching water with a bucket from a pipe connected to an open tank of water. The more the water flowing through the pipe, the more the quantity of water collected by the bucket. This law can be mathematically represented as M is directly proportional to Q, where M is the mass of the elements discharged at the electrodes measured in grams, and Q is the quantity of electricity or the total electric charge passed through the electrolytes, and it is measured in coulombs. The quantity of electricity Q passed through the electrolytic setup can be calculated by obtaining the product of current and time. That is, Q is equal to IT. This means that we can also represent Faraday's first law of electrolysis as M is directly proportional to current and time. If we replace the proportionality symbol with an equality symbol by introducing a constant E, we obtain the equation M equals to EIT, where E represents a constant known as the electrochemical equivalence, while I and T represent the magnitude of electric current measured in amperes and total time taken measured in seconds respectively. The key summary of this lesson is that Faraday's first law of electrolysis states that the mass of the elements liberated at an electrode during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. It can be mathematically represented as M proportional to Q or M directly proportional to IT. I strongly believe that you enjoyed this lesson. I will see you in the next lesson.